All right, so sorry about this. I don't know what happened with the definition of an inflection point. If the function f has an inflection point at cf of c, so notice you're going back to the original. If f double prime of c is equal to 0, or f double prime of c is undefined, and that's a huge and, if f double prime changes from positive to negative, or negative to positive, or if f prime changes from increasing to decreasing, or decreasing to increasing. So, excuse me. So essentially, you want to take a look at the second derivative, set that second derivative equal to 0, and see when the second derivative is undefined. Identify those values, and then check to see if you have a change in sign of that second derivative. Here's an easy example. F of x is equal to x to the third minus 3x squared over 2 plus 2x. So the first thing we'll do is find f prime of x. So 3x to the second minus 3x, right, plus 2. Then we find the next derivative, the f double prime. And so that's going to be 6x minus 3. We look at when f double prime of x equals 0, or when f double prime of x is undefined. It's never going to be undefined. You've got a linear function. So 6x minus 3 equals 0 when x is equal to 1/2, right? So if I go over and do a little test where this value right here is 1/2, and I essentially want to take a look at that second derivative, so I take 6x minus 3, choose a number to the left of choose a number to the left of 1/2, maybe 0, we get a negative value. Choose a number to the right of 1/2, and we'll get a positive value. So therefore the graph's concave down and then concave up. So we have an inflection point at 1/2 f of 1/2. So we have an inflection point at 0.5. I'm just doing that so that we can type quicker. And then I would put a 0.5 to the third, going back to the original, minus, and then I'd have 3 times 0.5 to the second, divide by 2, and then plus 2 times 0.5. So obviously you all could calculate that. So there is the big picture. If you wanted to look at a graph of the function, and I don't mean to just get wild and wacky here. Is there a blank? Nope, there's not a blank sketch. If I were to go here and graph x to the third minus, I'm just going to call it 1.5x to the second plus 2x. Ooh, look at 1/2. X equals 1/2. There's your inflection point. Hope this helped.